Hello, and thank you for watching the latest installment of Linear Systems Applications. We've been working on this for some time now, but I thought it'd be worthwhile to look at a couple of different kinds of problems to make sure that we get the hang of everything. So most of this is going to be review, so I'll go quickly, I hope. What we have here is two different car rental companies. We have the U-Drive and Safe Travel. And the U-Drive, they charge a flat fee, and it doesn't matter how much you drive. The Safe Travel company has a starting fee that's less, but they do charge you for your miles. So the cost is going to be different depending on whether you drive long distances or short distances. But what I'm trying to do here is try to figure out, is write an equation showing the cost. So the cost has to be one variable. And if the car is driven for X miles. So X represents the miles driven. Of course, I read M because I didn't read the problem carefully enough, but it's okay if you change the variable as long as the math is okay. So M miles driven for C cost in dollars for renting the car. Now, what's given is there's a $50 rental fee plus a mileage rate of $0 per mile. So basically, we can go into function mode here and just say, the C dollars starts at $50 and increases at a rate of $0 per mile times M miles. 0 times M is 0, so we don't even need to worry about it. In other words, cost equals 50. So if I drive 100 miles, 1,000 miles, 2 miles, 1 mile, it doesn't matter. I'm going to pay $50 to rent the car, period. Flat fee. Now you know why they call it a flat fee, because when you look at the graph, it's horizontal, just like that red line right here. Flat fee. Anyway, now you know. The second company has the same two variables, except I used S for cost because we have cost at one company and cost at another company. And the other things is the fees are smaller, but the mileage rate is larger than 0, of course. But still, I could still use the same dimensional analysis we've been using all along, and that is S dollars is equal to $30 plus $0.2 per mile times number of miles. Miles divide out, and we're left with 0.2 miles times, or yeah, I'm sorry, 0.2 miles dollars, 0.2 M dollars. Anyway, S equals 30 plus 0.2 M, and if you remember, this is actually like this is point slope form, or sorry, slope intercept form. So we have Y equals mx plus b. The slope is 1/5. The y-intercept is 30. So everything that we've seen before about linear functions comes true here. Both this linear system, both of these equations are in function form rather than standard form, which is why this is a little different from the others. But the math is actually much easier. First question was, if somebody drove 200 miles, I guess this is Greg, driving 200 miles, where should he rent? And it says that, it's going to cost $50 anytime you rent from the first company, but it's going to cost $70 if you rent from the second company, so the mileage 200 miles ends up costing me more. If you're only going to drive 200 miles, you better go with U-Drive. Or Jump Drive. All right, now what about 50 miles? Well, 50 miles will cost you $50, just like always at the first company. The second company will cost you only $40. So if you're only going to drive 50 miles, you want to ride with Safe Travel. It's not only cheaper, but by the definition, it sounds safer. Now we've got Philip. Philip actually finds that the price for both agencies would be the same. He's planning on driving how far? So in other words, what they're asking is, when will the cost for one company be the same as the cost for the other company? That is to say, how many miles would you have to drive in order to make their costs equal? So I can actually see here, 100 miles. According to the graph, by the way, I graphed based on the data that I had before. I had 0, 30, 50, 40, and 270. Those are the answers to my previous questions. Y equals 50 was pretty easy to graph, and my intersection appears to be at 100. So then I do the algebra. So remember, there's an algebra class. We want to learn how to do algebra. So I set the two costs equal and solve for M. And it's 100 miles, just like my graph said. And both companies will charge the $50 for a 100-mile rental. So there's that. All right, moving on. Here's an investment problem, and I don't know if anybody noticed this, but the investment problem is almost exactly like the cheese problem. We have two different things. We have total money invested, and then we have interest invested. And or not interest accrued rather. And just like in the cheese problem, there was a total amount of cheese, and then there's the percentage of fat. So here we have a total amount of investment and a percentage of growth from that investment. So anyway, it's going to feel the same. So the first thing I do, though, is I say how much should be invested in each. So that's the question I'm trying to answer, which means they have two different types of deposits. My variables will be dollars in the first type of deposit, that's bonds, and versus dollars in the second kind of deposit, which is bank certificates or certificates of deposit. So total of the investment is X plus Y. X dollars plus Y dollars is $150,000. That is X plus Y equals 150,000. And then the total interest in a year. So remember, that's the other thing, is year or time is not a variable, because we're talking about a 1 year investment. They want to make $12,000 in interest for 1 year. So in 1 year, I'm going to get 10 interest dollars for every 100 invested dollars. That's what 10% means, times the number of invested dollars. So for every $100 invested, there will be $10 in interest gained. Similarly, I'll have $5 gained in interest for every $100 invested if I go to the certificate of deposit, or the bank certificate. Sorry, having a rough day. So anyway, that will add up to the desired target of $12,000 in interest. So if they put so much money here and so much money here, I want the end result to give me $12,000 in interest, so I could take that money, use it to supplement my income, and keep the $150,000 in the bank. It'll just grow the same amount next year then. Just to do a little bit of cosmetics here, the first thing I did was I multiplied everything by 100 to get rid of the fractions over here, and then I recognized that all these are all three multiples of 5, so I just divided everything by 5, and I get much nicer, more manageable numbers to work with. My system now becomes X plus Y equals 150,000, and 2X plus Y equals 240,000. Now, without getting too much into the details here, because this is a review, to graph, I'm going to graph the x-intercepts, the y-intercepts for both functions. So that's what I do here, and I can do this stuff in my head now. And I plot each of the points on the x and y axis respectively, and it looks like the two lines intersect at $90,000, $60,000, and then I just do some quick algebra. Notice I use the elimination method here because I can eliminate the y's real easily and end up with just 1x equals. So the algebra here is a piece of cake, and that solution is confirmed. So I know that most people would be asking about this for the first part, about writing the system, and I hope that makes sense. What we're talking about is one equation for interest dollars and the other equation for total dollars. Just like before, we had an equation for total cheese, and then we had an equation for fat in the cheese. Same concept, different application, but the math is all the same. Now, the other question was very simple to adjust. They basically said, look, say they changed mind and they need $14,000, not $12,000. So all we have to do is write the first equation exactly like we did before. And then the second equation has the same interest rates for both deposits. However, I want $14,000, not $12,000. So this is the only difference between parts A and B. So I do the same simplification, and I end up with 2x plus y equals 280,000 instead of what I had before, which was 140. I don't remember what it was. Anyway, now my graph has changed. Basically, this green line is the new line in the graph, and it basically makes sense that if I want to get more money out of my investment, 14,000 instead of 12,000, I'm going to need to put more money into the high interest rather than the low interest. So if I want more money than I made before, put more money in the high interest and you'll make more money. That's just common sense, really. So once you get to that point, they're going to ask question C, why wouldn't you just invest it all in the AA bonds? Because you're getting 10% off of it. And that's just more of a theory of investment question. Basically, you never put all your eggs in one basket. You don't invest all your money in one thing. So if something happens to the AA bonds, which happened historically here in the last 20 years, then we would have some extra money in a different account to help cover ourselves. So it's called diversification, and that's what they're getting at with that last question. But there's no math to do in that one, so I'll move on. Thanks for watching. Have a great day.